Computer Science Principles. Unit 2, Review. You should have the notes so that you can fill in the blanks as we go. This is not a terribly exciting or a lot of computing. Most of this is things that you just need to know. So without further ado, within this unit, and I know they say 3A, 3B, 3C, 3D, 3E, they should say 2A, 2B, 2C, 2D, 2E, but you will understand how computers are connected into networks and trade-offs involved in building different types of networks. You will understand how computers are able to send information across a network using the internet protocols and routing. You will understand how websites are shared on the internet. You will understand how the internet has changed data processing and storage with distributed, parallel, and cloud computing. And finally, within this unit, you should have learned about and investigated and been able to describe issues that contribute to the digital divide. Within this review, this first recording is 2A, review 2A. There will be 3 different recordings so that you don't have to look at all of it or try to make your way through the whole thing all at one sitting. Lesson 1 was Welcome to the Internet. First, what is the Internet? In your own words, here are some examples. It's a web of wires and electrical signals, satellites and cables that send information that is floating above our heads. Seriously, someone has said this. Actually, the Internet started in the 1960s as a way for government researchers to share information. This was encouraged at that time as well because of the Soviet Union's launch of the Sputnik satellite, as well as the Cold War. The government wanted a communication system that would survive a nuclear attack. This eventually led to the formation of the ARPANET, Advanced Research Projects Agency Network, the network that ultimately evolved into what we know today as the Internet. ARPANET was a great success, but membership was limited to certain academic and research organizations: University of California, Los Angeles, Stanford Research Institute, University of California, Santa Barbara, University of Utah School of Computing. In response to this, other networks were created to provide information sharing. January 1, 1983 is considered the official birthday of the Internet. The official definition: the Internet is a global network of billions of computers and other electronic devices. And just so you know, you're really not going to be asked for the birth date, but it is interesting trivia. Now, in order to connect the global network, you first need to get access to it through an internet service provider. Examples would be Verizon, Comcast, Spectrum, Sprint, etc. Various ISP provide different types of internet services. Here are a few that you've probably heard of. Dial-up. This is generally the slowest type of internet connection, and you should probably avoid it unless it is the only service available in your area. Dial-up internet uses your phone line, so unless you have multiple phone lines, you will not be able to use your landline and the internet at the same time. Not many people have dial-up anymore, although this can still exist in very rural areas in the United States. Cable. Cable service connects to the internet via cable TV, although you do not necessarily need to have a cable TV in order to get it. It uses broadband connection and can be faster than both dial-up service. However, it is only where cable TV is available. Satellite. A satellite connection uses broadband, but does not require cable or phone lines. It connects to the internet through satellites orbiting the Earth. As a result, it can be used almost anywhere in the world, but the connection may be affected by weather patterns. Satellite connections are usually slower than cable. 3G, 4G, 5G. This service is most commonly used with mobile phones, and it connects wirelessly through your ISP's network. However, these types of connections aren't always as fast as cable. They will also limit the amount of data that you can use each month, which isn't the case with most broadband plans. And even if they don't limit it, a lot of times after you go over a certain amount, they'll slow it down for you. Now, the beauty of the internet is that there is no central location of the internet. It is made up of billions of servers, routers, and networks. There are no rules for where a network is or who can connect to it. Whoever connects to it though, has a motivation to make sure they can communicate correctly with all the other networks and devices connected to the internet, end-to-end connectivity. A computing device is a physical artifact that can run a program. Some examples include computers, tablets, servers, routers, and smart sensors. A computing system is a group of computing devices and programs working together for a common purpose. A computer network is a group of interconnected computing devices capable of sending or receiving data. A computer network is a type of computing system. End-to-end connectivity is a principle that anyone can connect to the internet and communicate with anyone else on another end at any time. Now, here we have a centralized network, okay? Here's our hub. It connects out. Notice this guy has to go through this one to this one. You do have a link through here, but you've got lots of spokes, okay? If the center goes down, we lose all connectivity between devices. If this guy goes down, only these guys are left. This guy can't talk to anybody. This guy can't talk to anybody. These two could talk. This one's isolated. This one's isolated. Not really a great way, to work. A distributed network. Why is the internet modeled off this type? Well, if a part of this network goes down, the devices can still be connected through other devices. If you lose this guy, for example, this guy still has connectivity. He can go around to get here. He can also go around and to get here. He doesn't have just one way, okay? So distributed networks are very useful for maintaining connectivity between devices. Why should we learn about the internet and how it works? Well, as Vint Cerf, who is the co-creator of the internet's architecture system, says, you can't escape from contact with the internet. So why not get to know it? Okay? You don't have to take Vint Cerf's word for it. Some of the largest issues facing society today hinge on an understanding of how the internet functions. Next up, we're going to look at our review about wires and cables. Lesson 2. The internet is a physical system that is made to move binary code between computers. What are the physical pieces that get sent to make the internet work? Well, simple example. Think of two houses that wish to communicate between each other. They will communicate binary code by agreeing that a light on is 1 and the light off is 0. Every second, they would write down if the light was on or off, 1 bit per second. They would then translate this into a message. This would work to communicate binary code, but it would be agonizingly slow, and prone to errors. We use this idea, but we send this information physically by electricity, light, and radio waves. Now, electricity. This works. This works similarly to our example above. However, like we stated, 1 bit per second is so slow and not practical. Plus, it is very prone to human error. So instead, we have machines that send and receive these electrical signals, translate the binary code for us, and then display the result. Computers can do this process very quickly. To measure how quickly, we use bandwidth. What is bandwidth? The bandwidth of a computer network is the maximum amount of data that can be sent in a fixed amount of time. Bandwidth is usually measured in bits per second, called bit rate. But notice that this is usually, not a hard and fast rule. The bandwidth to stream an HD video is typically around 20 million bits per second. To stream a YouTube video is around 2 million bits per second. Your ISP usually sets your bandwidth, either artificially or because there's a physical limit to how much electrical signals we can send at one time. The bandwidth on my home computer has an available download receive bandwidth of about 340 million bits per second. That's if I want to stream a movie. I can. The available upload send bandwidth is about 20 million bits per second. The average person is not uploading a movie and certainly not sending it to somebody watching it real time. Why the big difference? Most high-speed internet connections were designed for users who spend much more time downloading information instead of sending it. You can usually buy a customized plan from your ISP if you need more upload speed. Now that we've talked about sending and receiving electrical signals on our devices in terms of speed, let's talk about how quickly those bits travel through the internet. Well, latency. Latency is how long it takes data to travel between its source and destination, and it's measured in milliseconds. Satellite internet connection, high speed, high latency. You would click a link on a web page, and after a noticeable delay, the web page would start downloading and show up almost all at once. Theoretical connection, low speed, low latency. You would click a link on a web page, and the web page would start downloading immediately. However, it would take a while to load completely, and you would see images load one at a time. Cable internet connection, high speed, low latency. You would click a link on a web page, and the web page would appear almost immediately, downloading all at once. Okay? Next question. What physical medium do we send these electrical signals over? Well, an Ethernet cable is usually used to transmit electric signals between devices. The pro is that Ethernet cable is relatively cheap, but it does have signal loss over just a few hundred feet. So while it works great in your home, we really cannot use electricity to transmit bits over long distances. So what do? Well, we might use light. Light moves faster than electricity and does not have any signal loss when in transit. So we send light through fiber optic cables. It is a thread of glass used to send light. This is the most common form of internet transmission. It is why we have fiber optic cables across the ocean floors. The con is that it is fairly expensive and hard to work with. Radio. Wireless signals use radio signals to send bits from one place to another. The machine translates the binary code into radio waves of different frequencies to send. The receiving machines reverse the process and convert it back to binary. It allows our devices to be totally mobile, but a radio signal doesn't travel very far, which is why you can't get a good Wi-Fi. You can't get a good Wi-Fi signal outside your house. If you're in your home using Wi-Fi, your phone sends your bits through radio waves to a router in your home, which then transmits the bits to the physical wire to travel the really long distances of the internet. Bluetooth devices communicate directly with each other rather than sending traffic through an in-between device, such as a wireless router. Bluetooth devices communicate using low-power radio waves. Many devices that you may already use take advantage of this same radio frequency band, including baby monitors, garage door openers, and the newest generation of cordless phones. The cloud. The cloud is a term. Cloud computing. It's a relatively recent buzzword for a new type of computing. Thanks to the internet, Wi-Fi, and other modern networking technologies, individual users can offload much of their computational and data storage efforts onto remotely hosted servers. This has helped to make smaller, more portable computing devices, like laptops, tablets, and phones, more practical, because the device itself does not need to do all of the work. Instead, the heavy lifting can actually be handed off to the cloud. The cloud refers to servers that are accessed over the internet and the software and databases that run on those servers. Cloud servers are located in data centers all over the world. a lot of them here in Prince William County. By using cloud computing, users and companies don't have to manage physical servers themselves or run software applications on their own machines. A cloud data center is not physically located in a particular organization's office. It's all online. When your data is stored on cloud servers, it automatically gets fragmented and duplicated across various locations for secure storage. In case there are any failures, your cloud services provider will make sure that there's a backup of your backup as well. One of the key advantages that cloud computing offers is portability. The fact that your data can be accessed from anywhere in the world has had a profound influence on the way that people work and live. With cloud computing, it is no longer necessary to carry your data around with you when you can just download or stream it from a remote server. Of course, one of the trade-offs of storing your data remotely is the additional cost of transmitting your data to and from the cloud, both in terms of time and bandwidth. Client-server model. The client stands at one end of the communication process and typically represents the end user. The other end of the process is the server, a centralized computer that all individual end users connect to. In computing, this client-server model is the basic functionality of all internet-based communication. A client initiates a request or transmits data to a remote server, and then the server processes the request or data and returns the appropriate response. When you surf the web, your browser is the client. The website you visit is essentially data hosted, stored, and served on a remote web server. Who owns your data? Despite the advantages of storing one's data in the cloud, the use of online services and remote storage systems also come with a number of legal risks. For example, who owns your Facebook profile? You? Facebook? Clearly, Facebook hosts your profile and stores the raw data from all of your posts, comments, photos, likes, chat histories, and friend connections on their servers. But does that mean that Facebook owns the information making up all of that data? If asked, most users would expect that the answer is no. Facebook does not own their personal data. Fortunately, Facebook agrees. According to their terms of service, individual users own all of the content and information that they post on Facebook. But those terms of service also include a number of statements in which, by using the service, you grant Facebook permission to do a number of things with your data that may or may not be in your best interest. Legally, material created on a computer is the intellectual property of the creator. The use of the material created by someone else without permission and presented as one's own is called plagiarism and may have legal consequences. The use of material created by someone other than you should always be cited. When in doubt, cite it. There are various platforms that do allow you to use others' digital material royalty-free. Creative Commons. It's a public copyright license that enables the free distribution of an otherwise copyrighted work. This is used when the content creator wants to give others the right to share, use, and build upon the work they've created. Flickr, YouTube, Wikipedia, etc. Now notice, it's royalty-free. It doesn't mean that you can use it without giving credit where credit is due. Open source program. These are programs that are made freely available and may be redistributed and modified. Foxfire, Linux, Android, etc. Open access. Online research output free of any and all restrictions on access and free of many restrictions on use, such as copyright or license restrictions. Publication is defined open access when there are no financial, legal, or technical barriers to accessing it. That is to say, when anyone can read, download, copy, distribute, print, search for, and search within the information, or use it in education, or in any other way with legal agreements. Now, next up, we'll talk about packets, routing, and reliability. I'm going to stop this video here, so if you only want the first two, you can do that and come back and watch the next two later.